we are here for the M Billionth Award, and as it says, we are here for celebrating the mobile innovations.
Sir, please, mic here.
Is it essential?
Yeah, so we are here to celebrate the impact of mobile in our lives. So I thought it befitting that I should try to run my presentation off my mobile. It's going to be a little frustrating. Your patience is highly appreciated. So my first slide here says I'm here for the M Billionth session, and I'm here to talk about Smartur 3D. It's an augmented reality study app. What is augmented reality? So basically, there are two worlds we interact with on a daily basis. We have the real world that we are in all the time, and then there's a virtual world that we interact with more and more in the recent times, be it through your mobile screen, be it through your computer monitor, be it through the TV at your home, or screen at theater. So there are these two worlds. We are in the real world, and then there's a virtual world. What augmented reality does is bridge the gap between these two worlds. Augmented reality helps to bring the virtual world into the real world. How it actually happens is something that we'll see in the app. So before I go ahead with the app itself, I'd like to talk about what is the problem that we're trying to solve here. Learning is a very, very painful process. More so if you are a kid today, in today's times, where there are a million distractions. When we were kids, there were 1,000 distractions. Now there are virtually a million distractions. Okay? Kids' attention is spread across amazing cartoons on TVs, interesting games on mobiles, and stuff like that. Amongst all these, where does the content that they have to consume in terms of learning stand? In terms of its ability to appeal to the children. Okay? So this is the primary problem, that we need to create something that is of interest to the children. And we chose the path of picking up augmented reality as a platform to make learning interesting. Why did we choose augmented reality? See, learning happens in multiple ways. When something is learned, what does it mean? When I say, let's talk about fractions, something in your brain kind of sparks off. You think of a number with a division symbol in it and stuff like that. When I say algebra, some x's and y's and stuff like that kind of pop in your head. When I say, let's talk about dorsal anterior cingulate cortex, nothing sparks up. Because there is no memory engram in your brain for that. You've never learned about it. So nothing is coming up in your head. So learning basically primarily means providing a mechanism to build a strong memory engram in the head. See, we currently use schooling mechanisms that are decades old. When was the last time you heard of an innovation in the way teaching is done? The most forward-looking schools today are the ones that are supposed to be following something like a Montessori system and stuff like that. Montessori system was finalized or formalized in 1940s. Since then, what have we seen in terms of progress in understanding of what teaching means in the classrooms? Okay, so when we started to think about what's the problem we are trying to solve, we realized that the basic problem is to make learning interesting, and that primarily means providing a mechanism to embed a memory engram that is easy for the children to understand. How does memory form? So basically, there are two types of basic memories. One is a procedural memory, and there is a declarative memory. So in procedural memory, you have again two types. One is a motor procedural memory, and the other is a mental procedural memory. What is a motor procedural memory? Something like riding a cycle. It is something that you learn and remember for life. What is a mental procedural memory? A mechanism to do division. There's a mechanism, specific steps you follow. It's a mental procedural memory. Then we have declarative memory. Declarative memory again is of two types. One is semantic declarative, and the other is episodic declarative. Episodic declarative memory is what we learn from our environment. All of us are sitting here. This is the last session of the day. There are these lights here. You remember your positions where you're sitting. 1 week or 1 month later, you'll have memory of these locations, but you'll not remember a single word of whatever you heard. Okay, that's the truth. Why is it so? You're not making an effort to remember either your locations or the stuff that's being said here. But there is a process by which your brain remembers certain things, and that is the episodic memory. The declarative memory is the last form of memory, and that is what is used in the classroom. The semantic memory, the chalk and talk method, where the teacher draws something on the board and explains to the children. That is the first form of providing a memory engram. And augmented reality, by virtue of being able to bridge the gap between the virtual world and the real world, helps to build up memories that are episodic in nature. And that's the reason why we chose augmented reality to build our application. So a little backgrounder so you understand why we are going the way we are going. Okay, having given you this slightly scientific background behind the development of the app, I'll actually go ahead and show you the app itself. So what we have built is a Smartur 3D quick study app. This is a fairly young app. It was launched in March 2015. It was mapped to CBSE 10th class maths and science curriculum. Okay, this is what we launched in March. And in April, we launched another feature in it called the DigiLab. It actually composes of all the science-based models from grade 1 to grade 10. I'll just walk you through these two features. So this is completely mapped to the curriculum. The chapters that you see here are exactly the chapters that are there in the textbook. So let's say we want to see carbon and its compounds. This chapter is broken into multiple features. We have a study feature, a revision feature, a matching feature, but I'm more interested in showing you the augmented reality part of it. So if you see, there are these learning modules, and there are some titles here that tell you which content you're supposed to access. So for instance, first we have page 60, figure 4.1, 4.3, etc. We'll see the 4.3 feature. So this is a regular textbook. This is how it looks like. So there are these diagrams that have been made here. Teachers are supposed to kind of duplicate them on the board and explain to the children what it is all about. So what happens with augmented reality is this. Let's say 4.3 is what we are seeing. The 3D model of the same content that you're seeing actually gets projected to you. And there is a voiceover that explains to you what is happening.
Has 6 electrons, its L-shell, and it requires 2 electrons to complete its outlet. To do so, it shares 2 electrons, another oxygen atom, and forms an covalent double bond.
So this is working right out of the mobile on the textbook. This provides seamless visualization for the students. Here's something more. reality can be used to help children understand different topics. I've shown you something in biology, shown you something in chemistry and physics. So currently, as I said, it's a very new app. We just launched it in March 2015. So the first thing we did was launched it for the 10th class CBSE, Math and Science. And it's also been mapped to other board curricula which are directly in relation to the CBSE, like the Andhra Pradesh board and Telangana board. In April 2015, we launched the DigiLab, which is a set of all 3D models required in science across grade 1 to grade 10. So as you can see, all these topics mentioned here, it's an ever-increasing list of topics, and in each topic we keep adding more and more functionality. So it's going to be a little frustrating.
Yeah, just go ahead. I can understand. Yeah, sure.
So, as I said, this is the gallery that is composed of most of the content that is required for teaching in the classrooms. So, what has happened since we launched this app? What has happened is, since March 2015, there are about 30,000 students from grade 10 who have downloaded this app and are using it. Besides that, we have teachers from about 2,000 odd schools across India who have downloaded this app and they use it in the classroom. But the interesting thing is that more of the 2,000, more than 1,000 schools happen to be from the government domain. So that is something that is really heartening. We are quite curious to understand how these government schools are coming to know about it and why are they so interested. And when you kind of do a little research, we realize that most of the private schools are already bombarded with a lot of messaging from big education companies who keep calling them and keep pushing their products. Nobody ever goes to a government school and tells them anything about technology. The process of getting any technology into a school in a government environment is completely a complex mechanism and nobody's interested in doing that. So the teachers in the government school are so excited to be able to accept and use a product that is targeted towards them without any bureaucratic hurdles. They can simply go to a Play Store, download the app and start using it, and nobody in the world can stop them from doing that. As opposed to having to buy a computer or a projector, licensing software from big companies which turn into lakhs of rupees. So that's the most important aspect of it. And that was the main idea because Smartur 3D as a product was launched in US in 2014 June as a desktop solution. And we had a lot of traction in the US for this product. When we talk about augmented reality and stuff like that, they were excited. We have a lot of schools in the US who were using it. When we brought the same solution to India, we were absolutely devastated. The schools we went to, I'm not talking about the government schools, I'm talking about the private schools. They would love the product, but they said, where do we run it? Where is the hardware to do this? Most of the hardware is extremely old. It doesn't support the kind of horsepower that's required to run a 3D solution. Luckily, the mobile has come to our rescue. The moment we realized that it's not going to take off on the desktop space in India, we spent 6 months porting the entire Smartur 3D product to the mobile space and launched it in March 2015. And we saw immediate traction for it. We have teachers downloading it from across the country. I can just share some of the names so you can see for yourself. Okay, fine. Yeah. So that's it then. So I've shown you the product, I've told you where we've gotten there. And going forward, we will be adding more and more content. Most of the content is requested to the teachers. When they see something is missing in our gallery, they let us know and we add stuff to that. Besides the 10th class, we're also working on adding 9th and 8th class stuff in the next quarter or so. Thank you very much.
Let's hear the views of the panelists. Shall we start with Rajesh?
I think it's an absolutely fascinating piece of work,
Thank you.
and I have no doubt that I would have learned much more of science than I actually do if things like this were in existence when I was a student. My only thought was, obviously this is a product that you already had in the US, so probably you didn't have to, because I was just, as you were explaining, I was just wondering how much work has gone into
3 years of work was gone into this. 3 years. 1 year was spent in reading the psychology books, trying to figure out what is that trying to solve.
No, absolutely fascinating.
Thanks. Sir.
Sure, Samantha, let's hear.
Yeah, likewise, really fascinating. Just two basic questions. One is, does it really work mostly on figures? I mean, or those were
So
just the illustrations?
basically, not really. So basically, for augmented reality, you need to specify the 3D space. Okay, and the 3D space is set using something known as a marker. A typical marker looks like this. It's just a printout, a piece of printout.
Okay.
Wherever you place it, that becomes a floor kind of thing on which things are shown. So we mapped it to the textbook based on the teacher's requirement. Teacher says, give me the chapter number, give me the page number, give me the figure number. I don't want to browse and figure out where stuff is. So that's why we actually built the product in a way that is completely mapped to the curriculum. The digital app is not like that, isn't it? You can just pick up any model you want, just put your marker here, and then the model will come up on your hand. So the interesting thing was, when we showed this thing in the US and said, this is a marker, you print it out and we show it, and nobody kind of batted an idea. And then when we came to India and we said, this is augmented reality and you need to have a marker and you print on this. What marker? Where is the printer? Where is the paper? And then we said, okay, if this is India, there's no printer, there's no paper. Everything seems great within the confines of the city. You go 50 kilometers out of the city, it's a different world altogether.
Sure.
Every time I say talk about technology, they say, where is the chair? Where is the bench? Where is the chalk piece? Don't talk about all this nonsense. So what we did was, how do we create a marker that is universal? How do I create something? For instance, you download an app on your mobile, you're fascinated. Where do you get the marker from? You have to go to a place that has a printer and then download and print it. It's too much of an effort. So we said, what is it that we can do to kind of give a universal marker? And then we thought, and then said, yes, we all are carrying a marker in our pockets. And the marker looks like this. This is a 10 rupee note.
Yeah.
So if you place a 10 rupees note and show the mobile phone, the stuff comes on this. This is the frugal innovation that the Indians need to do, keeping the constraints that we live in a country like ours. And then we did, okay, why only India? In ambulance, we have people coming from Pakistan, Bangladesh, Sri Lanka. So all this money works. Wherever you are, pull out your purse, take out a 10 rupee note, and download the app, and you augmented reality for you. So these are necessities that we all have to live with, coming from a country like India, where everything is a challenge, where things that are taken for granted seem like gargantuan for most of us.
Also, just more out of interest, not like you have to answer it right now. I'd be very curious to know what kind of metrics you are looking at in terms of how it's really impacting learning.
So,
because I assume
yeah.
that for everything else that's technology based, there's a lot of beginner's delight with just the whole
Absolutely.
process of using the app
Right.
and trying something
So
else.
what we do is we track the downloads per day, and then we also track the content that is used on daily basis. So in my gallery, I have about 300 odd models across the different topics. So based on the daily usage, I have come to know what is of interest to people and where people are having a problem. So that gives me a direction. And also there's a feedback mechanism for the users to come back and say, this probably can be better, or there's an explanation that is possible. If you have seen that another big challenge that we had was, if you've seen the explanation, it was in English, and none of you had any problem with it. It was just fine for you. Again, you go 50 kilometers out of the city, where is the English there? There is no English there. Then what we said, how many languages can we translate this explanation into? And that explanation is dry. It's not going to appeal to everybody. So what do we do for that then? We said, can we get somebody to do these translations for us in all these multiple languages? We said, that is an impossible task. So we put a nifty little tool in that application. You click on it and you start doing your own voiceovers and videos. So inside the app, when the animation is playing, you just click on record, a video gets started created. And the video will have the teacher's voiceover. And then the video is completely customized in a particular language and appealing to the current user base of the particular teacher. And the teacher can simply WhatsApp it to the friends, or upload to YouTube or whatever it is. So these are the challenges that we are trying to address. So language is a big issue, and that's addressed by allowing the teachers to create their own content using the app, and it's just a click of a button.
Thank you. Brother? No, I had a very, I work at Cisco and we work very closely with the government schools. So I was a little curious because whenever we go to government schools, they are always overwhelmed by organizations trying to do something for the government schools. So how do you think that they are able to accommodate this? Because there's a lot of technology companies, the Intels, the IBMs of the world, the Microsoft, trying to put in their technology with these government
Yes,
schools.
the difference is when these big guys come in, they come with their own frame of mind. When we are building the product, we are actually building it to cater to their requirements. Okay, so when it's an app, for instance, when we did the first set of demos in India for the desktop product, the teachers would be very skeptical about operating the software. First of all, they don't have the intellectual wherewithal to use it because they are not the best of the breed. Let's accept it. Teaching is not the best and the most sought after job in the world. So they are a little challenged. And then there are lots of issues from the school management itself. They feel that, handling the software somehow spoils it and they're liable to pay for it if something goes wrong. So there are lots of baggage the teachers come with. So what we did was, so the mobile has come to a rescue for us because a teacher might never ever have used a computer, but they still do WhatsApp on their mobile phone. And as long as your product is as simple as WhatsApp, there's adoption. Adoption is the biggest trick. When the management is around, the teacher says it's a great product. When the manager is out, when I actually do a training session for the teacher says, why all this headache? I don't want to learn new software at this point of my life. When it's a mobile, they are a little more interested in trying to figure it out because they've already developed the habit of exploring stuff on their mobile as compared to a computer, which probably they've never used in their lives.
Thank you. Let's open the floor. 2 questions we'll take from the audience.
Hello. Just one question. What is the monetization model for this?
Yeah. So if you download the app, there are 2 options to sign up, either as a teacher or a student. If you're a student, for 10th class, we have the CPSE 10th and math and science curriculum. Each of those content is available at a fee of 250 rupees per year. Why 250 rupees? That's the price point of a textbook. So we wanted to have the product at a price point that the textbooks are available. If you sign up as a teacher, at this point of time, the content is free. So monetization is going to happen through the students who are going to pay for the content. And it's priced at 250 rupees per student per year.
Hi. Usually people go from junior classes to senior classes, but you have probably chose 10th and 12th senior classes first. And although I can understand why you chose them, but from my point of interest, I am more interested in junior classes, primary classes.
Exactly.
So do you have plans to
Yeah,
launch
so
this
if I had more time, I would have shown you the stuff that we built for the primary classes. We have the digital app, then we have amazing stuff for the junior classes that you're going to really love. I'll show it to you later.
Sure, thank you.
Thank you very much. We'll be very
Thanks a lot.
fascinating.
Thanks.
Shall we move to the next one?